Why is the thermal boundary layer key to convection? Imagine a hot cup of coffee cooling down as the heat moves from the liquid to the air. That tiny zone where the hot liquid meets the cooler air is what we call the thermal boundary layer. It might seem small, but it plays a big role in how heat transfers through fluids. The thermal boundary layer is a thin region of fluid right next to a heated or cooled surface where temperature changes happen. It acts like a bridge, controlling how heat moves from the surface into the flowing fluid. Inside this layer, heat transfer happens mainly through conduction, which is the direct transfer of heat from molecule to molecule. But outside this layer, the fluid is usually at a more uniform temperature, and heat moves mainly through convection, which involves the movement of the fluid itself. This layer is important because its thickness determines how fast heat can transfer. If the boundary layer is very thin, heat can pass through quickly, making the process more efficient. If it's thicker, heat transfer slows down. The thickness depends on factors like the fluid's properties and how fast the fluid is moving. For example, liquids like water or oil have different boundary layer behaviors compared to metals or gases. The Prandtl number is a key number here. It compares how easily momentum moves through a fluid to how easily heat moves. A high Prandtl number means the thermal boundary layer is thinner compared to the velocity boundary layer, which affects how heat is transferred. Engineers use this information to design systems like radiators, cooling fans, or even electronic device coolers, because knowing how the boundary layer behaves helps them predict how much heat can be moved away efficiently. The temperature profile within this boundary layer shows how temperature drops from the surface to the bulk of the fluid. This gradient is what drives heat flow. The steeper the temperature change, the faster the heat moves. So, understanding the thermal boundary layer helps us estimate the heat transfer rate, which is essential for controlling temperatures in many systems. Without the thermal boundary layer, predicting how heat moves in fluids would be nearly impossible. It links the surface temperature to the overall heat transfer process by controlling how heat is conducted and convected away. This layer is a key piece of the puzzle in understanding and managing heat transfer in everything from engines to climate systems. Knowing about it helps us design better cooling systems, improve energy efficiency, and keep everything running smoothly.